Yeah, yeah, actually, that's probably. Okay, we'll get started. Good morning, everyone, to the MENOG Peering Forum. Um, to start with, uh, this is the version 2, I think, of the MENOG Peering Forum, as we have called it. We've always had MENOG peering and IX related content at MENOG from the very beginning. In fact, one of the first presentations at the first MENOG was about peering. So this has been around for quite a while, but since last year, we've decided to call it the MENOG Peering Forum. And I still don't know how this is going to be structured and organized, but we have it here and we'll go through it and we'll talk about it. So I'm Gaurav Padaya. I'm on the MENOG Program Committee. And I volunteered to look after the MENOG Peering Forum this year. And I'll talk more about that later. The MENOG Peering Forum is an integral part of MENOG. The day one is more operational. The day two, we try to talk more about peering and IXP stuff. In the MENOG Peering Forum, we'll talk mostly about peering and IXPs. There'll be a mix of content between these two topics. But overall, it'll talk about the peering and interconnection ecosystem. In the region, outside the region, in the other parts of the world where we can learn from, and so on. And peering has been part of most of the NOGs for many, many years. In NANOG, there is a peering BOF. At Apricot, we do a Apricot Peering Forum, which is getting like one of the highlights of the whole. So then there is, in fact, in these areas like in the North America, in Europe, in Asia, there are dedicated peering forums as well, run at some other point. So there is actually a global peering forum next week in a ski resort somewhere in Canada. And then there is a European peering forum and Asian peering forum which happens. And in fact, there is even an African peering forum that happens now and then. So I think the MENOG peering forum would be a good thing to have. And, that's why we started it. So apart from panel presentation and discussion, we also have two very specific and sort of unique things, unique to the peering forums. One is peering personnel. It's basically a 1 minute, 1 slide presentation from a network. You come up here, I'll make you queue up here, and you send me 1 slide in advance that goes on the screen, and you have 1 minute to explain yourself. That's basically an idea behind, coming up here, telling people you're ready to peer, what your AS number is, so that people can talk to you later offline. So that's what we do. We have a template for it. The template, if you go to the MENOG 14 agenda and go through the peering forum agenda, there is a template for it. If you don't have slides, and a lot of corporations, they can't create slides because of their legal department, we'll just put your peering DB screenshot up here. Or you can come here and wave your hands to everyone. We'll also do IXP personals. Same rule applies, 1 minute, 1 slide presentation. We really don't have a template for the IXPs, but we request them to focus on not the history, but more on the updates or whatever is latest and recent. You can put graphs, you may not choose to put graphs or whatever, but we try to limit it to 1 minute as well. So today we have a pretty full agenda. The first one was me, obviously, talking about the peering forum and today's agenda. Immediately after me, I'll have Martin Levy. I know that peering personals are not commonly done. So what Martin will do is how to build an effective peering personnel and how to make sure your peering DB works and all of that kind of thing. Then we have Steve Wilcox, who will go through his long experience in the peering and IXP community and talk about how the role of IXPs and peering have changed over time, over the evolution of the internet. Then we have Bernd talking about his view on the peering status within the GCC and a bunch of his curiosities. Then we'll do our first peering personnel, which basically means that you'll have to email me between now and when Bernd starts speaking. So before the end of Steve's presentation, if I get it, it goes on the screen. If I don't get it, it goes into the next session. So same thing, we have next one will be a peering panel that will be moderated by Osama. And then again, at the end of that panel, we'll have another peering personnel. So if I don't get it before the break or if I get it next hour, it keeps on going to the next after the next. So there's no rush. The third one, we'll have 3 more presentations from Christian and Martin. Then again, peering personnel. So I'm hoping that almost everybody, any network who is in any IX anywhere in the world, will have a chance to come and do a peering personnel. And the last session of the day is more focused on IXPs. We'll have Arnold talking about the DKIX Apollon project, and then we have Jane Coffin from ISOC. Then we have Arnold again talking on behalf of the Euro IX board. Then we'll do a IXP personnels, which means we'll have all the IXPs give their 1 slide update. So then we'll do the peering personnel if I still have any left or if there is still time left. But I'm hoping all the peering personnels will be done by the 3rd sessions. And the last one is more about IXP personnels. Then we'll do closing formalities. I'm re-emphasizing this. What is a peering personnel? We'll run a 1-minute presentation at the end of every session. So it's 1 minute per network, not 1 minute for the whole session. I'm not going to parade you through the decks. You'll have 1 minute to speak. I have no limit on the number of speakers on this. And what I really request you, especially the global networks, is to highlight what kind of presence you have or planned or thinking about in this region. If you don't have any, that's fine. We have a template, which is, as I said, on the MENOG 14 agenda page. I also created a bit.ly link there if you really don't like to type stuff. So I'll put that on the screen for the next 1 minute for you to type. If you can't do slides or you don't want to do slides, wave your hands. And we'll see an email address in the next slide, and email me your ASN so that I can put up the appropriate info. The peering template is a guideline. You can put other stuff like a picture, a background picture, or your own picture on the slide, so that people know what you look like. I mean, this room is okay, but we had this at Apricot where the hall was so huge that somebody in the back of the room would not really see me up on the stage. So we started asking people to put pictures so that it is on the big screen. But anyway, you can add additional detail, but the rule about 1 slide and 1 minute applies to everyone. You can do it quickly, I don't care, right? But you can't go beyond 1 minute. We'll have you people pushing out. IXPs are also welcome to send their personnels for the last slide. This is what the template looks like. The main thing is please send your templates or your forms to this email address. That makes sure that goes to at least more than just me, and it makes sure that it gets on this laptop when you're presenting. If you have my email address, feel free to send it to me and I'll make sure it's here. But sending it to that email address makes sure that multiple people get it, and we make sure it gets on the laptop on time, right? It's fairly simple. As I said, we do request you to put in your peering DB entries, and Martin will talk about the importance of it. And then other, and this I'll come to later as well. We need volunteers for the peering forum part of the program. I mean, the program committee does a pretty good job of putting the program together. But if someone is interested to work with this, putting the agenda and program for the MENOG peering forum together, please talk to me or Philip or Osama or other members of the. Well, I think we have a different kind of colored tag here for the program committee. So talk to any one of us. But yeah, feel free to talk to me later on. The volunteers will help the main program committee to build the MPF program, probably bring in the right speakers. And if we like you, we'll volunteer you for a bunch of other things like chairing the sessions and into panels and things like that. Housekeeping breaks as usual. Breaks are scheduled for half hour, but I think we might shorten it a bit. Lunch as usual. We have a social event this evening. You can find the information out in the registration desk. So the next thing we do is Martin Levy. Martin Levy from Cloudflare. I need to get more practiced with that. Otherwise, I'll keep on saying Martin Levy, whatever, you can think what I say. So Martin is now going to talk mainly about how to do effective peering personnel and about peering DB. I'll put up your slides here, Martin.
We just got this one mic.
I'm just using this. I think there may be a. Today is Monday. This one? No.
Yeah, that looks like me. Is that a PowerPoint?
Yeah.
Okay, so. Well, first of all, good morning. It is quite great to be back, both in Dubai and in the region. And more importantly, it's great to see the progression of a peering forum in the region. For those people that have known me for a while know that I've been part of a group of people that really have been trying to promote and trying to see more interconnection inside the Middle East. So let me reintroduce myself. I'm Martin Levy, and I'm from Cloudflare. I joined Cloudflare about 3-4 weeks ago, but that doesn't change my core mindset of why interconnection is important. And, well, as those people that know me have been pushing IPv6 and the adoption of IPv6 for many, many years. But this is a particular area of interest of mine, which is how to be successful at requesting peering and how to be successful at an opportunity like a peering personal. And in fact, in reality, Gaurav has gone through a lot of this, but I'm going to go through some simple points. The basic premise of these introductions is that you want to meet and you want to successfully interconnect your network with another network. Connecting a network to a physical location and then not taking advantage of the other networks or content that is in that location seems a waste. And so that's where this idea of peering personals, this quick 60-second introduction, came from. And it's interesting that you can actually think of putting a 10 or 15-minute talk together about a 60-second process. But it turns out you actually need to talk about more. You have to talk about the follow-up from that, because 60 seconds is just 60 seconds. The process is repeated around the world. So the good news is what you learn here, you can repeat whether you're in Europe or in Asia or anywhere else. So I'm going to talk really about talk about two things. I'm going to talk about the peering personals itself, and of course I'm going to talk about peering DB as well, which is really the key follow-on from that. And I noticed that I noticed this was somebody else's slides yesterday, that there's a missing bullet on the screen. I don't quite know why. Okay, so what are these peering personals? And I took the liberty of being up here, of putting our own peering personals up there as an example. But there are some key points, and this may sound very trivial, but there are great examples of this hiccuping in real life. Make sure your network name, your autonomous system number is presented. If you are sitting here and you are not the network operations group, but you are maybe out of business development, or maybe out of sales even, or maybe out of an associate area involved in some other part, maybe the mobile side of a network, quickly send an email to somebody and make sure you know the correct AS number for your network. The autonomous system number is unique throughout the world. Every network has a unique number, and that number is the key component of any peering relationship. So getting that number out, and you will find certain companies that put that number on their business card or t-shirt or both. So the other question I get asked about peering personals is, well, should I present? And the answer is yes, absolutely, 100% every time. It never hurts to come up and say, even if you are about to say, today we do not peer, but we will peer in the future. Today we may not be in all facilities, but we intend to be in more facilities. All of these are valid. All of them get out to the audience, and it will stick. You've already heard where to send the PowerPoints. If you can't do a PowerPoint, just the simple textual information here will work. But let's break this down and make sure that this 60 seconds can really be explained and the value of it. The components are pretty obvious. This core information, as I said, and you have to understand that we've gone through this in many places around the world, and we've seen this hiccup occasionally. Repeat, repeat, repeat. So the name of the network. Now, I recently met with somebody from a small European network, a small European country, and they presented their network and they told me the name of their network, and I hadn't heard of it. And I did a very quick search, and I still didn't really hear of it. It didn't seem like they were an important network. And only halfway through the conversation did it become apparent that what the gentleman was using as his network name was his brand new marketing name that was probably a beautiful name, and was probably adorned all over the buildings that they owned around the country and the shops that sold their mobile SIMs. But he forgot to tell me that the old name of the company was so-and-so Telecom, which turned out to be the country's ex-incumbent, the biggest network in their country, which made the conversation instantly far more important. So the network name, as trivial as this may sound, it's important to make sure in the network space that you present the right name, because the name on the front of the shops in the malls or in the streets that is known by the population may be different than the name of the network that is understood inside the networking world. Put both names in there if you want to. But this subtlety, whether it be initials or a completely different marketing name, has actually come up and hiccuped people again to reduce this slightly. I've already mentioned the importance of the AS number. Again, some networks have multiple AS numbers. They may have a network inside the country with one AS number. They may have a network with an AS number that runs internationally. Think about which number is the important one to present. A lot of the other information is important but still secondary, because it turns out the number one thing, and Gaurav talked about this, that when we do this in Apricot in Asia, where we have a room of in some cases nearly 1,000 people, the contact and maybe even putting a picture is important. I didn't put a picture of Tom on here, but let's pretend I did. So the contact information enables the person halfway in the back of the room who says, oh, that's the network I need to find. And you can simply either get an email out right at that point, or you can at least save it away for later. That contact information is important. Which brings up an interesting point. Making sure that a simple peering at company name is available as an email and is supported by your IT group is just as important in the success of getting peering. We've seen some fairly complicated email addresses for various groups. There is actually a telco not based in Germany whose peering is run by their design engineering group. And their email address set up by IT is DE peering. If you say it quickly, it sounds like you're saying de-peering. Think twice before your IT group controls everything. And that network, by the way, stands behind that statement, but that's another story. The peering DB entry. You're going to hear me talk a little bit more about this, and those people that have heard me before know that I will talk incessantly about this subject, about how and why it is fundamentally important to build a peering DB entry. I will talk about that later. I'll talk about it now. So peering DB is the complement, the long-term sticky version of the peering personals. The peering personals is that 60-second punch to get people interested. The next part is where do they go for the details, the full details. Peering DB has been a database that has existed within the peering community now for quite some time. And it is operated by the peering community, and it is used to search out networks, to store information, to provide information about peering points, to provide contact information. And we'll have a look at some of that. Because if in reality, when you look at whether I should connect to an internet exchange or a network, peering DB becomes the near definitive source of that data. So this is an internet exchange point, the data that you see inside the peering DB system. You've got the navigation system, the classic ability to move around and see different parts of this database. You've got information about the exchange itself, including the contact information, whether it be the web page, the location, the email addresses, the IP address ranges that are in use. All of that is stored and saved on peering DB. And then you've got the members. And we'll talk a little bit more about whether this list is complete or not in a bit. It actually turns out it isn't, and it isn't by design. But this is where we see the information that will be useful when setting up peering. So all of this information is available for thousands of internet exchanges around the world. And most internet exchanges try and keep this data up to date as best they can. The other component is the networks. So here's a typical network page. Again, we seem to have the same type of information. We have information about the network. More importantly, we have the contact information, maybe more detail than you would have in a peering personals. Up in the top right-hand corner, you've got a list of exchanges, possibly also far more detail than you'd have in a peering personal page. IP addresses, sometimes you would have speeds in there as well. And then in the bottom, you've got locations, because sometimes peering is about physical interconnects as opposed to internet exchanges, the ability to run a fiber interconnect. So those locations become valuable. But a couple of points about peering DB. As much as there is a large amount of data in there, and you can see the statistics if you go to the website, there's also this. A simple abuse statement. Don't let your sales folks go grab this data and email everybody. There will be public humiliation. And occasionally people get banned, or networks get banned off of peering DB for using it. It contains very useful information. It contains the contact information of the networking group, the people that actually do the work. It contains a lot of useful data. So use it, but don't abuse it. All right, so here's the quick getting started. This is how we use it. It's 3 easy steps. You can follow along. 90% of people have their laptops open in front of them. So we can stop with the Facebook for a few minutes and run through this. Think of it like Facebook, but with IP addresses. The cool part is it really is set up for easy use. There's a guest login. The password is guest. You don't need to know anything else. It's right there on the front page. You can log in and you can read the information and do research. And in fact, for a lot of people who are looking at being interested in peering, whoomp, there's the data. They can log in and see it. If you actually want to apply for your own username and get access for your network, there's the information on the front page as well. peeringdb.com, and it's right there. The login is right at the top of the page. Type in guest, give it a try right now. Follow along. So, simple things to get started, the steps. Peeringdb.com as the web page. If you're going to set it up for your network, then use an email address associated with that network. Hopefully your work email address. There's always, and right on the front page, there's the support at PeeringDB web email address. You can contact them. It's run by a set of volunteers around the world, and those volunteers will answer the email fairly quickly. They are interested in helping you and getting more peering. Your network engineers, your peering coordinators, they can all register. Also set up your NOC address if you want to. Some contact information that is useful, because the other thing that PeeringDB provides is a what-if contact if you have a network issue. And to go a little further, and the support email will help you with this, you can set up your peering record for your AS number and set up your the relationship to all of those various emails addresses. So I've already said this, add your contacts, but if you actually start peering, if you're on a peering exchange point, then start adding those exchange points to the records. Tell people where you are. If you've already spent the money to connect to an exchange point, make sure people know that so that they can get to you and know that you're there. More importantly, if you've connected to an exchange point, start searching. Look up that exchange point on PeeringDB, look at the contact information, and start requesting peering. So this is what that sample network page looks like. I don't think it's 100% readable, but it again breaks down into 4 basic areas. The basic information about the company, the contact information. In this example, it contains the Network Operations Center, the peering request, the generic peering email address, and then 2 network engineers that deal with the networking policy. So they can respond if there's not a peering request, but just something ahead of a peering request. You add internet exchanges and locations. The internet exchanges are probably the most valuable entry there. The locations, if you feel like this is proprietary in some way to your operation, okay, make it an optional entry. But you'll find that it isn't really that surprising and hard to find out where networks are in the world. This is always an important subject to think about. Who actually controls this data? Who is in charge and who can edit this? And there's one really key point about PeeringDB. None of the internet exchanges get to edit this data. It is owned by the networks themselves. If you don't put the data in there, it doesn't exist. It means that you can put what you want in there when you want it. You may be connected to an internet exchange but not be ready to peer. So hold off on the data if you really want to. But the moment you put that entry in there, I can guarantee a few networks will probably send you an email saying, we noticed that you're at this exchange. Are you ready to peer? We would like to peer with you. And as the data is all maintained by the users, by those volunteers, if there are any issues, it is people within inside the community that are dealing with this. So I've talked about peering personals and I've talked about peering DB, but what actually happens next? And the answer is, you probably send an email. So I'm going to talk about emails, and this is my final note. And this is years of experience. If I could actually have collected the thousands upon thousands of peering emails, you would really see some examples of this. It seems trivial to say this is how you send an email, but it turns out in practice, over years and years and years, I've seen all manner of strange peering emails show up in knock queues, in peering queues, to the wrong person, or you name it. I love the ones that come in with the subject line, peering. When you're dealing with a network where you may get hundreds of emails into your knock a day, or you get peering emails that get archived, sometimes having a subject line that says peering is going to get lost. It's going to be hard to find in the future. We've seen the peering request in a particular city. We've seen just the city name. We've seen to whom it may concern, which is a very polite English, but doesn't help in the peering world. But then there's another problem. This interesting issue of what peering is about. Peering is the relationship between two networks. So when you get a peering request that says, I'd like to peer with you and I am AS 1, 2, 3, 4, 5, whatever the number is, keep in mind who the other person is that's reading that email. And then think about the response email that comes back. Because the response coming back will come from some other network, but with your AS number on it. It's sometimes very valuable to put 2 AS numbers and even the names of the networks into email. And if you think about this for half a second, think about what happens to that email when you want to search for it in a year's time when you may want to make a change, or there's an outage, or you want to increase peering. When you search for your own AS number, you're going to find them in a lot of emails. You want to find the other person's AS number as well. And over years and years and years, the only way around this is to make sure that both AS numbers exist in the subject line. And hopefully, some other information. I'd like to request peering. I'd like to expand peering. I'd like to turn up peering in this particular location. Or if this is a knock email, we have a maintenance window and we'd like to shut down peering for 24 hours or less. Think about the subject line as to how it's read by the other side. But also think about the content. Make it complete. I love the peering request. We've just shown up at this internet exchange and we'd like to peer. Our IP address is whatever it is. And they forget to put their AS number in there, or their contact information, or any other operational information such as how many routes they want to announce, how much traffic they think may occur, or even something simple like we don't want to run MD5 passwords. All of this in that one email at the beginning will help the peering process run smoothly so that you can go from peering personals to peering DB to actual implemented peering, and then walk away at the end of the day with a better network, which ultimately is what this is about. The final comment, we're all marketing people. We all have a marketing hat on to a certain extent. We may be network engineers, we may be managers, we may be whatever, but ultimately we're marketing. We are taking advantage of being given the microphone for 60 seconds to actually put the actually put the information out there. That's all I have to say. And I appreciate the time, and I hope that if you haven't put a peering personals together today, that you just quickly do that. Also, if you haven't got a peering DB entry for your network, put one together today, or tell somebody else to do it in your company. Thank you. I appreciate the time.
I don't think we'll do questions for you this time. Thanks, Martin. Next we have Steve Wilcox. So Steve is going to talk about the changing roles of IXPs and what role they play in the internet ecosystem. And this is a very interesting presentation. And in the PC, when we talked about it, and we said that only Steve can pull it off. Steve, to you.
Really? Thanks, Gaurav. Just a quick introduction about myself. So I'm Stephen Wilcox. I'm the founder of IXReach. I'm currently the president and CTO of the company. I think most people know what our company does, but in case you don't, we're a global wholesale provider of connectivity, selling to carriers, the leader of providing remote peering, and we provide a range of services in the wholesale and carrier space. And I think we're in 16 countries and 30 cities. So just looking back to the early days of the internet, how did the internet come to be? I think most people know that the internet was developed in the US out of a military research program. The commercial internet that we have today really came into existence in the early 90s. A number of networks started to operate a commercial backbone, and these original networks came together and were what were known as the tier ones in those first days. The tier ones were the national operators in the US, and if you were entering the internet market, you would buy transit from a tier one, whether you were a local ISP, tier 2, tier 3, whether you were a content player. Everybody bought from the tier ones. They were the center of the internet in the 90s. Because the internet was developed in the US, this also meant that much of the content was coming from the US. And some of the early websites, and nowadays you see some of the global websites, Google, Facebook, all have their origins in the US. What this meant was that once the internet spread globally and it spread into other countries, typically what would happen were providers would set up local internet companies and they would connect to the internet backbone by buying long-distance circuits. I saw this in the UK where the companies would be buying these small circuits across the Atlantic to buy transit in places like New York or in the Ashburn area. What this meant was that the local operators were paying a very, very high cost. The transatlantic circuits in the 90s were ridiculously expensive, and international circuits globally were very expensive back then. So it was a very expensive business to have this internet that was centered on the US and all the traffic being hauled in and out. It also meant that once you started getting more operators in a particular country, that these operators all were operating these international lines. And to exchange traffic from my network here to my neighbor's network here, we would go in and out of the US. And once the internet started to grow and the traffic levels increased, you started to see guys coming together and say, hey, this is not a good use of our money, and we could probably do something here. So what you started to see was the introduction of exchange points. And most of these early ones were either set up by academic or research networks, or in some cases the ISPs would come together and collaborate. And this was happening around the early to mid-90s. This is where you see the origin of most of the names that you would know. So as this has evolved, 20 years on from then, we now have about 400 plus internet exchanges around the world, of which the great majority of them, and the largest of them, are located in Europe. A few of these are classed as international hubs, the names that you know, the AM6, DKIX, Lynx, France IX, but there's a lot of other smaller IXs as well that either operate as a secondary IX in a market or operate regionally in another area of a country or something like this. But all are important in the way that they play their part in the topology of the internet and in helping traffic to move around between operators and between content, and to stay local and to improve the quality of the internet, and also to help it scale. The largest IXs that are out there, the traffic volumes that they're seeing are in the multiple terabits. So this is comparable to tier ones, the largest content providers. And as these guys are growing, what we're seeing is that they're expanding their services. Typically what we're seeing with the largest IXs is that they're either expanding themselves within their metro, or they're moving into other cities, either in the same country or in different countries. IXPs are considered to help to develop a market as well. I was trying to find some data which I found after I'd submitted the slides, but I found this interesting quote on an OECD report. It was talking about Lebanon, and they were saying when the exchange point was set up in Beirut, they saw within a matter of months, so before the exchange, all the traffic was going international and going through transit. And once they got the exchange locally, they saw a 425% increase in the traffic levels over a period of months, which is it's pretty interesting to see that all this traffic, it doesn't just appear out of nowhere. It was latent there, and obviously the ability to exchange it in affordable and uncongested links enabled it to grow. So this is just an example of what an internet exchange point looks like if you're not familiar with the workings of them. They're basically just layer 2 Ethernet networks. ISPs coming together and exchanging traffic over these layer 2 networks, but to reach the scales that we're seeing with the terabits, the architectures are becoming pretty sophisticated. So this is the example of the DKIX, their new platform, in which you see a number of different technologies being put together in order to create a platform that can scale to the terabits and be stable. And if you look at the traffic growth that you're seeing, this is the DKIX traffic stats again, it's roughly doubling every 18 months to 2 years. And this is actually a trend that's been observed for a while in internet traffic, looking at exchange points. This is the Lynx graph, has pretty much exactly the same slope to it in growth. And the AM6 graph on an exponential curve here, pretty much exactly the same, doubling every 18 to 24 months. So what are some of the things we see at IXs? Just a few points and facts. Tier 1s are present at internet exchanges, and they do peer. A lot of people think that internet exchanges are the realm of the tier 2s and the contents, but no, the tier 1s were there from the early days, and they're definitely active. But you see the activity to different levels. They're typically restrictive in how they want to do business, and not really open to peering with just anybody. In contrast, the vast majority of the numbers of the participants at internet exchanges are open to peering, and most networks will peer with you if asked to do so. The sheer number of networks that you now see at an internet exchange, 400, 500 plus at the largest exchanges, mean that they've started offering ways to make life easy for you to peer. So most of the IXs have a root server now. You peer with the root server, and you will see every other network that peers with the root server. And I think something like 50 to 60% of participants at a large exchange are peering through the root servers. So you can get a huge amount of routes and access to the internet just through bringing up 1 or 2 peering sessions after you join these exchanges. The other thing about peering at internet exchanges, most of the peerings that exist do actually see traffic. Networks that you see peering in many, many locations, they're not just backup links that they have sitting around, they are actually active sending traffic. The largest IXPs are looking more and more like networks in the way they're operating. They're exchanging the same levels of traffic as them, so they are looking like them in technical ways and in non-technical ways. For example, some of them offering SLAs, starting to innovate on the products and doing things like reseller programs which are using VPLS and technologies to make this happen. And as I mentioned before, they're expanding in different ways as well. They're entering into different locations, either using their brand, like France IX when they opened in Marseille, or UAEX, powered by DKIX. And we're also seeing them appear in the US market. Recently, the OpenIX initiative moved forwards, and we've seen new exchanges open up in the US from Lynx, AMSIX, and DKIX. This is what the largest IXPs are doing. What the smaller IXPs are doing is they're innovating in a different way. They're innovating in their product set. So they're typically providing value-add services over their platforms, or in some cases, they're even offering services to connect to the larger exchanges. There's a couple IXs now that offer remote peering services from their platform directly to the largest IXs. And I think it's becoming increasingly difficult to tell the difference between international, local peering networks and exchanges, as everything's just becoming much more global and coming together. The peering patterns that we see around the world, places where there's no peering infrastructure, this usually means that there's higher bandwidth costs. This is pretty much an analogy of what I was saying before happened in the 90s when the internet moved outside of the US. If you don't have local peering infrastructure, if you're paying for international links and if you're paying for third parties to carry your traffic, it means that you're going to be paying more for your bandwidth. And we do see that. And that there's places in the world where there isn't a good exchange of traffic locally. I mentioned the Middle East as one such location, which until recently had very little in the way of internet exchanges. And some parts of Asia Pac are like this as well. It's a lot of countries don't have much peering infrastructure, and the traffic is carried out of the country. In the US, by comparison, it didn't have the same drivers that got it to where it is. So the different parts of the world evolved in different ways. In the US, we saw some of those early operators actually start to operate exchange points, and then those moved into the realm of the telcos. But in summary to those slides, having IXPs does help your traffic to be local, gets rid of your costs on the international traffic, and it creates an ecosystem for business as well. You see content, you see businesses, you see all kinds of businesses, finance companies come into a location where you have a hub. If you have an active market where there's an internet exchange, a number of networks saying that they're present in a particular building or city, beyond those internet providers, you will see the rest of the ecosystem follow, and you will see that your economics increases, and the business that's happening will grow. This is just a graph of data from EuroIX, but it actually shows the number of ASNs that are present in internet exchanges in each region. I think it's quite interesting actually, because in Europe you see there's a huge number of ASNs that are present in peering compared to other regions. Even North America is such a long way behind because of the way that the peering has evolved in the US, and because of historical reasons and the lack of non-profit internet exchanges, you see a lot of peering in the US occurring privately rather than on the public internet exchanges. But Europe is pretty far ahead. Another bit of interesting data source from PCH. They did a survey on peering partners, who do you peer with, and they picked some examples out of here. I think the US, the UK, and the German examples are interesting. The Russia's an anomaly, but it shows that about a third of the peerings that a particular operator will have in an exchange are with domestic networks. Quick recap on the difference between peering and transit. Peering is a settlement-free interconnect between two networks. You're just exchanging your customer routes. You're not providing access to non-customer networks to the rest of the internet. It's usually cost efficient because it's settlement-free and occurs in a mutual location, and it usually leads to low latency and quality flow of traffic between them. Transit, by comparison, transit's a commercial service. You buy it from an operator. The operator provides you access to the global internet. By nature of this, it's always going to be more expensive, and you have less control over what happens once you exchange your routes and your traffic with this operator. I wanted to add a little note about the remote peering, because I mentioned it a couple times in the slides, and it's also something that we do a lot of as a company. I got this figure from AMP6's 2012 annual report, but 75% of all AMP6's new members in 2012 came from reseller partners. And I just got a text this morning saying that to date in 2014, 74% of new members have come from reseller partners. So since the introduction of resellers, it's really helped to drive the numbers of networks that are able to get out to internet exchanges. In a typical reseller setup, it basically means that you're long-lining to an exchange. You have no local infrastructure. There's usually a bundled price model. So it's reducing the costs, and the operational complexity to turn up is fast, because you're not having to do any deployment. It's all managed by your provider. What this means is that it's increasingly becoming cost-effective for smaller networks, smaller medium-sized networks to reach out and peer, and even for large networks to go well beyond what they consider to be their territory, to go out to exchanges in other continents and justify the cost of this. And this is really driving the growth of the number of participants in internet exchanges around the world. Just how that looks technically, you have your ISP, in the traditional peering world, you have your ISP. You would go to a colo, you would buy a rack of colo, you would put your equipment in, you would connect to the internet exchange. Physical hardware connected together. In the remote peering environment, you have your network, you buy locally from your provider, and the provider will carry you to one or multiple exchanges over this NNI link, and there's no deployment of infrastructure from you out there. When you are at an internet exchange, you see different types of peering relationships. I think Martin was going into this in a little more detail on his presentation, but they're usually categorized in different terms, which are now drop-downs on the peering DB, but they're usually categorized as open peering, meaning I will peer with pretty much anybody. Selective, meaning, well, I'll take a look at you first and see what I think. I'm open to it, but show me what you got. And then there's the restrictive, which usually means that they're not open to adding new peers except for exceptional circumstances. What this usually means is that similar sized ISPs will peer together. So if you're a small or a medium ISP, you'll typically find that other small medium ISPs will peer with you. The larger guys might not want to. And similarly, the larger guys will peer amongst each other and will decline the peering with the smaller networks. When the peering is declined, when a larger network perceives that it's not in their interest to peer with you, you'll see them try and sell transit services, and these larger networks are acting as the transit providers, selling into the smaller tiers. So, roughly speaking, you have your tier 1, your tier 2, your tier 3 ISPs. Your tier 2s buying from your tier 1s, your tier 3s buying from your tier 2s. Not exclusively, you can buy from tier 3s, can also buy from tier 1s, but at least for the purpose of a diagram, this is how we think the internet works. And when we talk about tier 1s, tier 2 through tier 3s, tier 1s are the networks that typically have the larger number of traffic and routes on their network, and a larger geographical scope. And the tier 3s are usually a local network operating within a smaller geographic region, smaller routes, and generally smaller traffic. 10 years ago, if you were to make a diagram of the internet, it would probably look a little bit like this. You would have your customers buying from the ISPs, your ISPs peering together with IXPs, and the core of the internet was generally in some way considered to be these global tier 1 backbones. And we also had content out there as well, but content was smaller back then than it is now, and content typically was peering the IXPs or buying from the large networks. The way it's evolved, we've seen content really take off. Content now is huge. I don't have a percent to quote, but I would guess that big content these days is sort of 70% of traffic that's flowing out there. So content has actually eclipsed what was the tier 1s, and content has built out global networks, and content now peers directly with ISPs. They have infrastructure directly within ISPs, and this has meant that the amount of the traffic that's carried by the historical tier 1 networks has decreased as a result. When we look at peering and what peering is, a study a few years ago showed that 99.5% of peering is done on a handshake. It's done at meetings like this, peering forum meetings, operator meetings. You meet someone, you say, hey, I want to peer with you, and peering is set up. People look at the network size, they look at your traffic ratio, and they'll make a decision to peer. The bigger networks, I mentioned before, a little bit more discriminating, and they may or may not agree to peer, or they may agree to peer, and then at a later date they'll look at you and say, hey, your traffic's changed, your ratio's changed, and I'm not so happy anymore, and I want to de-peer you. And this creates pressure on some networks to pay them to continue to peer. And if you refuse, you see a standoff, and at some point you might see disruption on the internet when two large players come to de-peer. There's a bunch of examples of this happening, but the bottom one in here is pretty interesting, and a very typical example that was analyzed, Cogent and Sprint. Sprint wanted Cogent to pay, Cogent didn't pay, and they got de-peered. And because both of these networks were acting as tier 1s, when they de-peered, there was no other way for these networks to connect to each other. Neither network bought transit from a third party, and now they'd disconnected. So actually you saw over 500 networks globally that were unable to communicate with each other because of this de-peering, until some alternative arrangement was put in place. So, how to avoid issues such as finding parts of the internet unreachable to you. Don't rely on a single transit provider. make sure you have multiple transit providers, and make sure that you do good capacity planning. Make sure you build out your peering. Peer directly with networks that you consider to be important, and overbuild on those peerings. If you only have a couple gig of traffic to a network you think important, but it's settlement free, why not put a couple of 10 gigs in different locations, and you're going to scale and you have failover. And if some traffic is very important to you, be prepared to pay for it. There's a lot of paid peering out there these days, and I think it was a dirty word a few years ago, but now it's quite common if there's something you want to access and the partnership isn't equitable. And multi-home, say buy from multiple transits, go to multiple internet exchanges, spread your traffic out as much as you can this way so that any particular incident doesn't affect you too much. So I'll just wrap it up. So what are we seeing in the trends and the evolution of peering? We're seeing smaller networks becoming more global. The costs of going out there into the world is allowing increasingly small networks to go out far beyond their borders and peer directly. We're seeing a shift in what is carrying most of the traffic on the internet. We're seeing content really dominating as the main player in driving traffic growth, and we're seeing the traffic that's traversing tier ones decreasing as a result. And we're seeing this thing that's been termed donut peering. If many networks are able to peer with each other because they're all getting to these same locations, all these end tier 2, tier 3 networks, all these domestic networks are now able to peer directly with each other, and they're peering around what was the core of the internet. And this has been termed donut peering because they're all peering with each other and not into the core anymore. And we're also seeing content being pushed directly into network operators. Many of the big content players have caches now. They don't even bother to offload this traffic through transit, through internet exchanges. They just put the content directly into your network. And as that's growing, you're seeing it going deeper into the network and into cities and individual exchanges and things. So that's me done. Does anybody have any questions?
Any questions for Steve?
So they either all understood it really well, or we're all on Facebook.
Next I have Bernd. Let me load that. He's going to talk about his experience.
Thanks. My name is Bernd. I know the name is a bit different. I got many different names here in this region, so don't worry. Thanks for MENOG giving me the stage here. I try to talk a bit about what I think the peering situation looks like here in these days. So I would like to to start with maybe some kind of crazy idea, just to assure that everybody has waken up. So I try to give a picture of what I think what can be a perfect network in terms of low latency and good round trip time. So when looking at the cities, sorry if I forget important cities, just invent a new GCC supercarrier, and how to make it perfect is rather easy. Just draw as many lines as you like and concatenate it all together. So this will bring some good latency in this region. Now let's bring in this theoretical model some interconnections, and yeah, I think this should do the job. Go from maybe Cairo to Europe. In Yemen, you head to sub-Saharan Africa. Oman should be the place for South India, and so on and so forth. And now, okay, where should the content be located in such a theoretical model? Quite in the middle, I think, yeah. So it will assure short round trip times to the to this network, yeah. But now bring up some questions. Would such a network be fast? Yes, of course. Would really give nice round trip times to all the countries, to all the cities, to all the content. But what is the name of this supercarrier? Yeah? STC, Etisalat, DO, Deutsche Telekom, China Telekom. Who should operate such a network? So this is why it's just a theoretical idea from a technician side. Politically, it's not possible, and it would work nowhere, even not in Europe. So don't mind. This is just to a beginning of the story I want to tell. So idea one was crap. Was not really good. A second idea: how can be the round trip times perfect in this region? Yeah? It's a quick idea number two. Everyone should pick the same IP transit, and this will do the job. Of course, this one IP transit should go for a network like in example one, and everybody's happy because the traffic then stays in this region. But as we all know, this is also a theoretical model because it will not happen. Yeah? Everybody chooses the tier one which he likes, and they do whatever they do. So let's have a look where the real challenge is located, and keep in mind that I'm talking about short round trip times and the ideas of a full mesh network. So let's look at Saudi Arabia. Saudi Arabia has more or less 4 large players which are in the role of making cross-border connects, have the filters in place and so on. So making a full mesh in Saudi Arabia is not that complicated, so I think this is done. So shouldn't be an issue. Yeah? Look to UAE. Okay, we have 2 players. A full mesh is not really complicated. Just build one line and everyone is happy. Yeah? Also very easy. But then bring in some other countries. Yeah? I think this is more or less the number of players for the other countries. Kuwait, I think we have 4 to 7 larger players. Yemen, 1 player. Oman, 2 players. Qatar, Bahrain. So let's try to bring all these networks together in a full mesh that everybody has a perfect network connections to the other. So I start with 3 countries. A full mesh between Saudi Arabia, Yemen and UAE. Okay, this looks possible, yeah? You have 7 players, means 21 direct links for a full mesh, and everybody has a perfect round trip time. Okay, then let's try this one. Okay, I added Oman, I added Qatar, Bahrain, and I skipped the idea of bringing also Kuwait in place. Sorry, Bahrain was also left out because too many lines. With this example, it means 23 players means you need 253 interconnects in this region. And this is not the end of the story. So we have still no content in here. So then let's add some content. Content with a full mesh that everybody's happy with short round trip times looks like this. Yeah? So it comes up to 325 interconnect. And this is still not the end of the story. But because now we have more gaming, more content, more players, more international players, so no picture of that is possible. And it means if you look at the numbers, with, for example, 100 players in this region, a full mesh would mean near to 5,000 interconnects, which has to be built for a full mesh network. And the number of players here is quite more than 100, I would think. So the conclusion is this model does not scale and nobody would pay. It's not working. So what is the outcome? As the full mesh is not possible, the job of having a perfect network has to be done by the existing private peers which are in place, plus the role of the tier 1 carriers that they run the interconnection. So I give you some pictures from the days before an internet exchange I'm working for has arrived. Yeah? So this is a bit looking in the last months, but the picture has not rather really changed these days. So I did some trace routes in this region. Trace routes can be done by everyone. Just pick a looking glass, enter a target, hostname or IP address, and do the trace route. And if I do a trace route, example number 1 from Dubai to Dubai, everybody would assume, okay, this must be done in 1 or 2 milliseconds. And I've hidden the name of the carriers, but I know them. So this is the picture when I do a trace route from Dubai to Dubai. I tell you, you can falsify these pictures very easy, because when you do 100 tests and you find something bad, okay, you got some bad pictures. But the truth is you do around 15 tests and get to around 10 of these worth looking examples. So it's, I think it's normal that this picture happens, and I give you some more pictures. So the outcome here is 25,000 kilometers instead of maybe 20, and 260 milliseconds instead of 1. So example number 2, let's try it on the other coast, Jeddah to Jeddah. Means this is a landing station, means 0 kilometers. So the expectation is again 1 millisecond. And this is how Jeddah to Jeddah does. The good thing here is Marseille is doing a great job. So Marseille is becoming more and more the route instead of passing Gibraltar. And this is nice, but it's Europe again. Test number 3. I tried with Kuwait to Dubai, and to tell you, I typically picked tier 1 looking glasses and mixed them all together, so this is the source of my tests. And when you do Kuwait to Dubai, it should be around 50 to 100 milliseconds, and this is how it really does. So I'm not sure if it's really getting this way. But you see clear New York, it's in it, and Singapore is in it. So I think this picture is quite what it really is about. Then I really like the trace routes from Dubai to Dubai. Yeah. Another example, another pairing, another tier 1 combination, the same result. We are in London again. Then let's try Dubai to Jeddah. Yeah, expectation 50 to 100 milliseconds. And yeah, no surprise, it's again Europe. The same pairing with other carriers, Dubai to Jeddah, same result, no difference. So what is missing? Yeah, peering, interconnections. This is why I was talking about the full mesh. A full mesh is not in place, not from the operators here, not from the tier 1s who are serving this region. Last example, Dubai to Oman. I really like this picture. 30 to 50 milliseconds could be possible, and this is where it goes. Yeah, US. So, yeah, what is the conclusion? Important. All networks I've chosen because these are great networks and I really like them, and they're quality networks. So it's not about blaming carriers or operators or the region. It's just the logic of IP, which is the outcome here. And what I also have to add, thank you. You're financing the cheap prices in Europe. So this is why we have really, really cheap prices in Europe, because you're paying all the links and exchanging your regional traffic in Frankfurt, in Amsterdam, and in London. So thanks for that. But this must not be the future. So let's look at another example. Still the topic is round trip time. So looking a bit at the DNS route system, this is a really fundamental base of the internet, and you can also make some round trip time checks to the root servers. And as we know, we have around 4 of 13 root servers in this region. They are called with iRoot, FRoot, KRoot, LRoot. And if you look at the round trip times from the RIPE probes, you see that these 4 root servers are quite okay, so around 20 milliseconds. This is nice. But where are the other root servers? Yeah? They are far away. Means when you have 13 DNS resolvings, you have 4 good ones and 9 bad ones. So there's still some missing on this side. And by the way, where is IP version 6? You have all configured it, you have all peered it, I think. So, yeah, example number 3, still the round trip time stuff. Round trip time to major content. I've taken this picture in November, and this is what I've seen. When you do a round trip time check from, in this example, seen from a network in Riyadh, you see the blue numbers. This is in comparison the situation in Europe, and the other are the round trip times from Riyadh to this major content. And I've chosen the typical ones, so Audi, BMW, Apple, Akamai. This is typically driven by Akamai. Then Limelight, Yahoo, CD networks, Google, Twitter, Facebook. And you see in Europe it's more or less going close to 0 milliseconds, because this stuff is highly redundant everywhere, except Twitter. This also comes out of USA for Europe. But you see that the round trip times are really high, so it goes up to 500 milliseconds. And the story is this content is mostly in this region at the time where this test was taken. So the content is here, but it's not reached on a short path. So there's something missing, and it's again peering. So while I'm standing here, and attention, here is some marketing inside. UAEIX is one possibility to bring a solution here, because UAEIX is a bit, or is the idea which is successful in Amsterdam, London, and Frankfurt. So in Dubai, UAEIX is running. It brings together the networks, and it changes things, because international content is coming to the region, regional content comes back to the region, and now the thing is changing, because international players are now paying on their cost to reach this valuable region where we all do business with. So this was part 1. Part 2 is a bit shorter, very shorter, just some peering curiosities which I see from the daily operation, what operators present to me and to the other guys. And this is also a bit of technical, so don't wonder if you understand all examples, but I show you. So curiosity 1 is missing prefixes at route servers. So when you compare the members and you compare the number of prefixes which are advertised in Frankfurt, you see in this example 50 networks in Frankfurt, but only 44 in Dubai. So there are some missing prefixes, and this you can watch on various examples that the announcement, the advertisement base is different, but one of the rules in this scene is that typically you should have the same announcement on all internet exchanges. Example number 2 is having a route server configured but sending 0 prefixes when having more than 1,000 is also a bit curious, so it means you do nothing. Or it can also be an example that you have this more than 1,000 and only announce a subset. So this is very often seen that not all prefixes are in place because of saving money or having too less bandwidth or whatever. Example number 3. This is also fantastic. You just make use of one side. So this is just outbound traffic and no inbound traffic, which means the network engineering ignored the learned prefixes. And what is the danger in here? As you've seen the picture where the traffic can go around, this leads to a heavy, unbalanced, asymmetric round-trip time picture, because the one side is perfect, the other side is very far. So example number 4, and we're close to the end. Missing ripe entries in the routing database is also not a good idea, because if you don't have your ripe entries done perfectly, you get filtered. And this is what this example shows, that the member tried to announce prefixes and the prefixes are filtered out because of missing ripe entries. Example 5 out of 6, 10G peering board, and you see a line at the point of 1.2 gigabit means this operator has a backhaul of 2 times STM4, which hits at 1.2, of course. So this is about having 2 less backhaul. Last example is seen a prefix, an announced prefix announced from 3 carriers with 3 different sources with the same AS path length. This is kind of really technical, but the point is the one location, the source location is Frankfurt, the other one is Paris, the other one is USA, and the outcome is that this prefix, you cannot say what the source, the fixed source is, because the rule of BGP is the first established BGP session does the job, and this can lead to varying results that you cannot say where the prefix is coming. And this topic, I would make some suggestion if you're interested in this kind of question. And just look for Andy Davidson, traffic engineering at Google. You'll find a great presentation about this traffic engineering stuff. And yes, that was it. So thank you for your time.
I'll get Bern to come and do Q&A later, because we really have to do this now. So I've sent emails to those who are on the first round of the peering personnels. So let's get done with that. We missed it. So my plan was to get you all running out at 11 o'clock, but you got a pre-warning. So anyway, Kevin can come up here and we can get started with the peering personnels. So it is Kevin, MMC, Freddie, Jim, and Martin in this round. So please line up.
Hi, good morning. I'm Kevin Epperson. We're racing the fire alarm, so I'm not going to read everything here. Long and short, Microsoft has a pretty large network, 60 IXCs. We have IXs. We have a limited presence in Middle East. We're working on that. What I would be interested in talking to folks about is hosting cache nodes for Microsoft. So if you are a member of a network that would like to host a rack of our servers, you'd like to provide 30 amps, 10 gig port, a little bit of cache fill, I would be very interested in talking to you at break. So thanks very much.
Thank you, Kevin. Jim, after this.
Matthew from Amazon. We're not currently present in the Middle East. This slide is about where we're closest to the Middle East. You can see a couple of our AWS regions or where they're available. So if you've got traffic to the different ones, that's where to meet us.
Thank you, MC. Well, his name is Matthew, just. Jim Cowie from Renesas.
Hello again. Renesas, as we said yesterday, does internet measurement and research. We would peer with you, but we would send you no routes. We would send you no traffic at all. We guarantee it. What we do allow is we give you a complimentary subscription to our Renesas routing intelligence tool in exchange for a full BGP table, not just your customer routes, but your entire perspective as seen from your own vantage point. That's about 500,000 routes these days. Yes, I have a private AS number. I have a real AS number, but I will not use it with you. You can meet us at links, M6, DKIX, etc. by multi-hop peering. We are not currently in the region, although we have tried. We were at the IST-X in Istanbul, which unfortunately did not really attain critical mass. But you're welcome to meet us where you can, and we are more than happy to peer with you in both V4 and V6. So thanks. Peering at renesas.com.
Thanks, Jim. Next is Freddie.
Hey, good morning. My name is Freddie Künstler. I tried to win the contest who does the nicest peering personal slide. I hope I win. We are one of the alternative backbones around. We don't have a presence yet in the region, but we're working on that. The closest geographic point probably from that perspective is Marseille. We have a POP. Whoops. Is this the sign that I won? All right, so at least everyone is awake now. Please come talk to me if you want to peer or if you're looking for an alternative to your big name transits, where I'm here open to talk. Thanks.
Martin.
I've been here, done that. So, same information that you saw earlier. Again, we don't have cache boxes in the region either, so I'll replicate the comment from Microsoft that we're looking for locations for those as well. So come talk to me during the break. If you are present either east or west of here, let's say in Singapore or Hong Kong or in all the usual suspect places in Europe, we're open. I know we peer with some of you already. So open peering policy, which is pretty consistent with content plays, and AS13335.peeringdb.com for all the specific information. Thank you.
Thank you, Martin. I think I'll bring you up to remind, I think I'm a bit disappointed that we didn't see any presentations or proposal from the region. So I'll try to, this is what we need, you know, and then the template is available at that link over there. Please try to send more. I have a few more already, but I need more. And I got a lot of exchange point presentations, so I don't think we'll have peering personals in the last one. So you know, yeah, something wrong about that. More exchange point people being more active than networks. So please send your peering personals. And if you send it to me, but I didn't make it to this one, it probably means that it came a bit too late for me to put it in the deck. So you'll see the slides in the next, after the break. So we're running half an hour on time. So we'll have a break, 20 minutes, and then come back here for the panel. And as I say again, please, if you are a network, even if you don't peer, you know, it's okay to come and talk about or present your network. And something you might want to do is all these 5 people who presented the peering personals in the first round are veteran peering people. So if you have any questions about peering, go talk to them, or go talk to Steve, or go talk to Martin or someone. You know, they'll help you understand this ecosystem better. Thank you very much. See you in 20 minutes.